Hi everyone. In today's lesson, we're going to talk more about the definite integral with trigonometry. Today we'll focus on three more integrations with trig. So let's recall the derivative of cosecant of u. So the derivative f prime we know is negative cosecant of u times cotangent of u times the derivative of u, or the derivative of the inside. So if we're just given f of x, which is equal to cosecant of u, we can say that f prime, or my derivative, is equal to negative cosecant of x, cotangent of x, and then technically we'd have to take the derivative of the inside. The inside here is x, so the derivative of that is simply 1. So we really don't need this 1, it's just this. All right, now let's talk about secant. So the derivative of secant is secant tan. So again, same thing goes. If I have f of x, which is secant of, say, x, then the derivative, f prime of x, is simply secant of x tangent of x. Again, times the derivative of the inside, which is 1. And then last but not least, the derivative of cotangent is negative cosecant squared of u times the derivative of the inside, of which is u. So say I'm given just regular cotangent of x. The derivative, f prime of x, is simply going to be negative cosecant squared of x times the derivative of this inside, which is 1. So what I just proved is that these three things, if I take the antiderivative of them, I will get these three things. So the antiderivative of negative cosecant cotangent, where did it come from? That's going to be cosecant of u. And since there's no definite integral here, we can just put plus c. Now, if the derivative is secant tan, where did that come from? Secant. So the antiderivative of secant tan is simply secant of x, again plus c. And then last but not least, if negative cosecant squared is my derivative, then my original is cotangent. So the antiderivative is cotangent of x plus c. So we're going to use these three trig derivatives to answer some integrals. So let's do one of them together. Example number 2 here says, evaluate the definite integral and express your answer as an exact value in simplest form. So if I want to integrate negative cosecant squared of x, that's going to have to be, this one, right? Integrate negative cosecant squared. That's going to give me cotangent. So cotangent of x that I want to evaluate from 0 to 3 pi over 2. So I'm plugging in top minus bottom as usual. So cotangent of 3 pi over 2 minus cotangent of 0. So remember on a unit circle that the x value is cos of theta, the y value is sine of theta, y divided by x, or sine divided by cosine, is tangent. Therefore, x divided by y, the reciprocal, cosine theta over sine theta, will be cotangent. So this is the one that we need. So let's take a look at that. We're looking specifically at 3 pi over 2 and at 0. So remember, 3 pi over 2 is equivalent to 270, and 0 is simply just 0. Okay, so now if we're looking for cotangent of 3 pi over 2, we have to look at this point, so I'll highlight it in blue. And we need to divide the x value by the y value to get cotangent. So the x value here is 0, and the y value here is negative 1. So 0 divided by negative 1 is 0. And then we also need cotangent of 0. So here's 0 degrees or 0 radians. And we're going to do the same thing. We're going to use this point, which I'll highlight here, and we're going to divide the x value and the y value. So the x and then the y. So then we have 1 divided by 0. Now, 1 divided by 0 is actually undefined, right? We're not allowed to divide by 0. So is it possible for me to take 0 and subtract an undefined value? I don't think so. So what that means is this answer is not possible. So this answer as a whole is undefined. So it's not possible to evaluate this. All right, let's try another example. Okay, so now we have the antiderivative of 2 cosecant cotangent. So I took the liberty of copying the one that we need. So over here, the antiderivative of negative cosecant x cotangent x we know is cosecant. So since this is positive, we're just going to negate the answer instead. So the antiderivative is going to be negative, but then we need the 2, right? We're going to follow down the 2 that's always there. So we're going to just say negative 2 cosecant of x. And we want to evaluate that from pi over 4 to pi over 3. So again, we've got our top and we've got our bottom. So we're going to plug in negative 2 cosecant of pi over 3 minus negative 2 cosecant of pi over 4. If it helps, you can use brackets to separate the two things that you're subtracting. And now we're going to try to simplify it. So since it's asking for the exact value, we probably need to use the exact value chart. So pi over 3 we know is equivalent to 60 degrees, and we know that cosecant is the reciprocal of sine. So sine of 60 is rad 3 over 2. So we're just going to flip that, and then that's going to give us cosecant. So 2 over rad 3. And then don't forget to bring this to negative 2 that's in front. And while I'm here, I might as well simplify. I can put this over 1 and multiply straight across. So negative 4 over rad 3. Now let's keep going with the next term. So cosecant of pi over 4. We know that cosecant is the reciprocal of sine. We know that pi over 4 is 45 degrees. So sine of 45 is rad 2 over 2. So we've got 2 over rad 2 if we want to flip it. And then don't forget to bring down this negative 2 in front. So again, you can put the 2 over 1 and multiply straight across. So negative 2 times 2 is negative 4. And then the bottom is radical 2. And we want to subtract them. So obviously we could put this in our calculator and get a decimal, but I'm asking for an exact value. So we're going to have to simplify this, which is what we have. So we've got negative 4 over radical 3 minus a negative 4. So I'm just going to make it plus 4 over radical 2. And we know that we need to make a common denominator, right? We can't add them unless the denominators are the same. So I'm going to multiply this top and bottom by radical 3. And I'm going to multiply this top and bottom by radical 2. So radical 2 times negative 4 is simply negative 4 radical 2. And then the bottom, rad 2 times rad 3, you can multiply those and get rad 6. And then the tops here, 4 times radical 3 is simply 4 radical 3. And the bottoms, rad 2 times rad 3, which again is rad 6. So we can add fractions as long as their denominators are the same. So we keep one denominator and simply add the tops. Only we can't add them because they don't have like radicals. So we get to leave our final answer like this. All right, so what I'd actually like you guys to do now is see what you can do with problem number 3. And remind me to go over this one in class tomorrow. We'll call this one homework. All right, guys, that's it. Have a great night.